Okay, thank you very much, everybody, to the organizer, first of all, TT especially, and all the local organizer, and of course, to all the people participating to the conference and to the people attending this session. I hope you can see my screen. I try to be to cover. I don't know how much you see. Can you see? Just give me a feedback.
Yeah, it's fine.
Do you see my screen? Okay, okay, wonderful. Okay, the idea that I ask you to give me a check about the time. It's about 25 minutes with the all things, but you never know. And the idea to cover is that how marine remote sensing can support or can be related to sustainable development. And I just made the present affiliation. I underlined, of course, University of Naples, Partenove, and I'm affiliated with the NGB as well. But I just want to remember, this is very special to me, that some years ago, not too many years ago, I was in Cagliari. So most of the colleagues were very, very close to me. I hope you can see. I just have to scroll. This is the table of contents. We'll move from the very general introduction, which covers some, let me say, economical, environmental concept, and we'll especially emphasize how some paradox are, let's say, common sense idea around. Then we'll move to very, very general idea description of how microwave remote sensing, especially from satellite, can support. And the topic of this report is to contrast the idea that images and measurements, data, information, and these kind of things. So to underline something that, again, must be taken in proper consideration. Then we move to some ocean application. In the paper that have been written, there are even more. And of course, there are more and more. And then we'll draw to very short conclusion. This introduction, as I told you, is about paradox. And the first paradox is related to something that apparently doesn't, I mean, is a loose relationship with the marine environment and environment itself, which is the gross domestic product. And I don't want to read it, but let me say in very simple terms, we say if the GDP is high, the economy is rich, the people are rich. And so let me say simply, the economy in one country is better to another, the people live better than in other places of the world. If the GDP, you can sometimes measure per capita, so divided by the number of citizens, that country is higher. And under this, there is even a large, let me say, popular publicity or saying that there is a chance to have an unconditional GDP growth. And even more, I just extracted from an economist paper, so let me say liberal paper, a liberal journal that was well known, recognized. There is even a relationship or a study about the relationship about the GDP and the growth of GDP. You can see this, let me say, kind of vector. So for example, this is the starting 1 year in 2005, and this is the India point in 2018. Okay, just say that the GDP increased during this year. But if you measure the happiness, which is a scale from 3 to 8, whatever, so if you are higher, you are happier. This means, for example, that according to this survey, in India, although there was an increase of GDP, there is no more happiness than before. This is different in China. China is lucky in this sense because, of course, they had, compared to India, a smaller GDP increase during these years, I'm saying, but they are happier. So there are even studies, let me say, not only to say that you are richer, but even that you are happier, although this is controversial. To be honest, the GDP parameter, single parameter, as an indicator of the richness of country of the people is very controversial. I just give you some hints about this, but why this is important for us? because of course we are interested in the ocean, and the ocean for most of us means that to spend some leisure time in summer, but it's even a very important economical factor. And here are simply summarized as apart from, of course, the obvious and let me say clear impact of the ocean over the climate, and they even very important for economic sectors. And according to a recent report, for example, if you only focus about fishing, the seafood is very, very important economy. And you can see in the paper all details. It's kind of trillions or 3 trillions value of the economy of the ocean. So oceans are not only environmentally important, are even economically important. This is the first way. Now let's go to sustainability. What does it mean, sustainability? It doesn't mean, I mean, in modern language, as I said, there is a word that will replace, let me say, sustainability for the ocean, which is called blue economy, which means economic growth preserving the environment. Let me say in very, very simple terms. Here, you can find, I wrote here the number of the ocean economy. How much is the value? It's about 3.6 trillions, okay? Million of a year, okay? Which means is a very important economical factor, okay? That's the relationship with GDP. And so let me say, I just underline again, this is, let me say, kind of repetition, because saying blue economy implicitly means sustainable, but sometimes we forget, okay? We take for granted blue economy as ocean economy, which is also true, but means sustainable. So is it possible how is possible to have a sustainable blue economy, which is a like kind of revolution? And I inspired by Prince Charles quotes that you can read on the right side. And he says in very simple terms that sustainability is a revolution, okay? Just say this, I don't want to go, I just put here for your future thought and insights, but I move to a very, very important paper, which is very famous, but sometimes neglected by most of the people implied in policy and in technical things regarding the ocean in particular. And this paper is a 1968 paper, let me say it's a fundamental paper by Hardin. And I just want to come across, it's a very complex paper, but I invite you to read it. You can find the download freely. It's I give you the reference at the end, but it's even on the paper that I prepared. And it's inspired about the study of the common land, which means, let me say, commons as it is, for example, the environment, or can be the ocean. And what does he underlines? He underlines that by paradox, by logical thinking, critical thinking, I would say, that the sharing and the preserving of the common goods in general, it focuses on common land or regulated pasture about common land, but it's a general discussion, of course, cannot be made simply by technical solution. What does it mean? It means that actually you have to consider, if you want to preserve the environment, not only introducing new technology, but even changing, he calls human values or ideas of morality, which means, let me say, the values that you consider in whoever is more deep into economical terms, means that the environment is an externality, is like not an inner variable of the economical problem, and they say it's out of the problem, so you can exploit to do whatever you want. And the other point he underlines, which is in contrast with the GDP idea, is that a finite world, a finite resource as an environment, can support all finite, limited population, which is, of course, means that something which is finite cannot be infinite. So this is in contrast with GDP theory, which predict or support that there is a growing and growing GDP over the world. Apparently, I said this in very simple terms, this complex paper, this economical paper relating with economic environmental things, seems very, let me say, naive, very obvious. But actually, which is the real goal of Harding, is to contrast the spirit of Adam Smith economy model. It's like Maxwell in electromagnetic fields. It's like Einstein in physics. You understand? So what I say at the very end of this paper, that the model that we use is the economist model, is a liberal model, is the model of the most of the countries in the Western world. Adam Smith says that the interest of the society is made by giving free enterprise to the single individuals. So let me say, the best for the society comes from the best of the single person, which is the liberal theory of economy in very simple terms. So at the very end, he contrasts the most important economy theory, which is the liberal one. So that's the point. So what he says at the end, I say, this is false, cannot be possible. And so this is what he call the tragedy of commons. So I say, if 1968, I want to underline this, no? Since today talk, but it's 50 years or something years old. And he says that, of course, if you want to preserve, let me say, the common goods, the environment, for example, or the oceans, you cannot proceed with, let me say, the liberal Adam Smith economical work. In model terms, if you're interested in models, if you like to say, you have to introduce in your model the environment as a finite resource, okay? No more externality that you don't consider. And this passage is a revolution. So I connect to Prince Charles' statement, which means changing the impact of our values. So what he's saying that in this sense, he says, it is not only a technical advancement. Today, in Italy, for example, there is this misconception about sustainability, but it's a new paradigm, it's new way. Okay, I don't want to go in all details, but it's very important. And for example, means that with respect to Smith, Adam Smith theory, we have to impose what he calls freedom limitation. And in this sense, let me say the satellite measurement, the micro remote sensing can be important to this. So let me say in very simple terms at the end. So sustainability is not a perturbatory concept. It's not a big, small change, improving some techniques. It's a big change in economical paradigm that can be supported by technical tools or means, or in this case, micro remote sensing. And let's come to our, let me say, side, which is more technical, being aware that is only a tool over a very, very big change if we want to proceed and not make what they call greenwashing instead. So I want to illustrate a green advancement, not a greenwashing advancement. I just go very briefly, but I like to start from very basic, of course. The fundamental things about micro remote sensing, I would say remote sensing in general, is that Maxwell equation works and means that propagation, electromagnetic fields propagates, and so they can interact with the land, the ocean, and whatever, and so change their characteristic, like getting some imprinting of their peculiar geophysical change or whatever. Just some picture. I don't want to take a longer time about this, but it's just want to say pictorially. Can you see?
10 minutes.
Quanto?
10.
Okay, thank you. And one concept I will come across very, very, very briefly is about polarization. So apparently, it's a small change. The electromagnetic field can propagate, let me say, in different ways along different planes, which are here summarized. VV, which means transmitted along this plane and received about this plane, or transmitted horizontal and receive horizontal, and or a combination of the two, which means transmitted H and received P, or vice versa. Apparently, it doesn't change too much. Let me say a very simply way. I show one case. Let me say the image, because I show some image, they are the same. What does it change very much is the phase. I show one case, so we'll see. Just a small hint about this important peculiarity, which is a very close connected, for example, with the new modes of the Cosmos Skynet second generation, but not only. In very general terms, we can say that remote sensing works because electromagnetic waves propagates, and there is an interaction between the electromagnetic waves and the scene, which is monitored, the OSensor in our case. On a very conceptual idea, the remote sensing can be framed as a measurement forward model, which is understanding the relationship between the geophysical model, quantity of interest, and the inverse model, which means in this picture means that once that you have the footprint, the tracks of the dragon, understand which kind of dragon been walking or generated these tracks. I don't have enough time to go in all details about this, but I just want to underline that, of course, the direct inverse problem are, or the forward and the direct problem, inverse problem, are not at all identical. And let me say very simply that inverse problem is more complex than the direct model. But this means that one thing is important. The measurements that are made by microwave remote sensing in general, whatever the sensor, must be interpreted, must become information. Of course, there are many frequencies can be used. I will focus only here on microwave remote sensing, just to mention. Okay, we can split between active and passive sensor. I don't want to detail too much because I consider that all of you are well aware, but I just put for coherency, so everybody. And of course, each remote sensing sensor can be described by some external, let me say, resolutions, not only one: radiometric resolution, spectral resolution, spatial resolution, and the temporal resolution, which is I put in blue because it's also dependent on the platform. Again, I go briefly, and what I say is this at the end: data and information are not the same, and data is something that must be interpreted, must be analyzed to get out the information. This is very fundamental, because too many people in our field still today call for more data. Of course, data we may like to have more and more, but it's not enough. Fortunately, it's a field that we need a human expertise, the skill, the capacity to extract information, which means we need you. Okay, that's I'm okay. I'm okay with that. I just move briefly with some OSEN applications, some showcases. Okay, I go to the large scale. First of all, passive radiometer, passive. Okay, large scale. We can monitor, for example, here, an hurricane. This is an operational application, very valuable, as can you read over here. So it's not environmentally only. It's economically relevant, and it's operational. Okay. In this case, of course, the value of a large-scale sensor is evident, is clear, because you can see this A, B, C, D, and it's a time analysis, which means the observing of this hurricane during the days, and you can see that the growing and decay of this hurricane. Of course, you can use even the spatial L-band, the microwave radiometers, to exploit something which is very important for the climate, which is the sea surface salinity. And here you can find the map. But you can even think about some, let me say, small scale analysis or application, where you can use, for example, the synthetic aperture radar. I moved to this because, of course, I focus especially on this, so I skip some other sensors because it's very relevant for Italian community because of this Cosmos camera, second generation and first generation. Is the pictorial view only of the first generation. And in this case, the revisit time is limited by single SAR satellite or satellite. But if you have a constellation, as in the case of Cosmos K-Med, you can enhance the temporal resolution. I just saw some cases, I hope you can see. For example, this is a monitoring of offshore wind farm. We are in North Sea, on the UK side, for example. You can see these small dots. This is very important for monitoring the turbines and the offshore wind power. Of course, you can do many other things which are very important. But let me say, for example, in this case, enforcement of the respect of rules. I just want to show another application similar to the other one, but different. This is a Sentinel-1 image, and you can see the Gulf of Suez where there was the accident, the Evergreen accident, Evergiven in the Suez Canal, and you can see that more and more ships had to stop and not enter the canal because of the blockage due to this accident in March 2021. So you can use even for monitoring, let me say, ships, which of course is a topic which is related very much to industrial fishing or illegal fishing, which is one of the most important environmental and economical factors. Here is summarize why it is, okay? So let me say, for example, the picture I want to show you is that the overexploited, let me say, fishery, in all sense, including aquaculture, is growing and growing. Okay, so that's why I show this example, giving the chance about the possibility of the SAR to monitor these, let me say, legal or industrial overexploiting fishing. I move to the final one application I want to show you is about oil spill. Oil spill is a complex. We've been working a lot. I can detail much more, but of course I have 1 minute probably. And it's not one problem. It's a large problem with many facets and many things. This is a big accident happened in the Pacific, and you can see here apparently how simple they may appear. There's dark patches of SR images, but this is not true. This is not true for many reasons. Okay, this is only something that you show when you want to sell your products, and I show you in this case the benefit. It's only one case I show you for polarimetry. So as I told you, when you have a BV and HH SAR images, they are apparently very, very, very similar. I didn't show you the two gray tones images in HH BV, but apparently they are very identical. Not apparently, they are the same. The phase changes. And so if you use, let me say, a copolar phase difference, you can monitor with the physical ground the heavy dumping load, which is very, very important, especially in very critical areas where the damping area, the dark area are not easily to be classified as oil spill at sea. I hope I was in time. We are at the conclusion, not long conclusion, but just to say, sustainability cannot be reached by a perturbative approach to our economy, style of life. Of course, the underlying question is sustainability valuable? Do we need really sustainability? Do we believe that's worthwhile? And this is a question for you, first of all. And let me say, let's move to the third point, or the white point is, of course, technologies can support a new sustainable policy. And in particular, the microwave satellite remote sense can provide key information. And this is almost the end of my talk. And I just want to show you, let me say, very, very clean, a very beautiful place without oil pollution. And I want to invite you to submit your contribute to a special issue I'm coordinating on sustainability. And You can find the link over here. Finally, I have a comeback to economy wars. John Maynard Keynes is a British economist, but as you may know, he was much more popular in the United States than in UK. And with this statement, the biggest problem is not to let people accept new ideas, but to let them forget the old ones. And this is sometimes very, very, very. Thank you very much.